welcome to the second series of the topic on geometry and trigonometry. Solomon Saduma here. Now, the topic geometry and trigonometry is, we split it up into 6 different parts. Some of this will be higher level material, and the first part will be the standard level material. This is the second part of the discussion. The first part being on the basic trigonometric identities, basic trigonometric ratios, as a matter of fact. Okay, so the second part is going to be on triangle rules. We will go into this shortly, but let's first of all just lay it down into how we will tackle this. The skills and understanding on triangle rules is going to be, we will look at the area of a triangle rule, how to find the area of a non-right angle triangle when you're given 2 sides and the angle between them, or you're given 2 angles and 1 side, and so on. Okay, after that, we will look at the sine rule. Sine rule is about finding the length of an unknown side of a triangle or finding an unknown angle, all right? Then after that, we will look at the cosine rule. The cosine rule is also about looking for an unknown side, but the way we use cosine and the sine rule will be different. We will see when we'll discuss or briefly try to understand when it is best to use the sine rule and when the cosine rule is better. And of course, after that, we'll look at application of the triangle rules, both in bearing and navigation and other areas like construction and so on, okay? Before we go on, I just needed to put this into context for those who also study physics or chemistry. If you do not study physics or chemistry, does not mean anything, does not make this difficult in any way. But let's just take a look and see what's going on here. What I have here is a simulation. I want to try and relate laws of triangles with what we refer to as Gauss laws in physics and chemistry. So what you see here is a simulation. I am going to use this pump here. So I have a container of some known volume, and I will use this pump to push some molecules inside the container, okay? So I can push, every time I do that, I put 20, so that's already 40, and that makes it 60. So I have like 60 particles inside the container. The behavior of the particles is described by something called Gauss laws. In particular, what we refer to as the equation of state. You don't need to memorize that if you're not a chemistry or physics student, all right? We can, so like I said, the behavior of the molecules of the gas is determined by something referred to as properties of the state. And the properties of the state of a gas are the pressure, which is going to be measured by this instrument here, the temperature measured by the thermometer right there, okay, and the volume, which we can measure using, we can place a ruler here, and we can use that to measure the length of the container, which in turn is proportional to the volume of the container. So the properties of the gas, the properties or the factors that determine the state of a gas are the pressure, the volume, and the temperature. This temperature is thermodynamic temperature measured in Kelvin, okay? And the rule or the Gauss law that is relevant to this says that if you change any of these 3, the other 2 will also change, so that the ratio P times V over T is always constant. So this is always constant. And this is what we refer to as the equation of state for a gas, particularly an ideal gas, all right? So you can see I could increase the temperature of the molecules by heating. So this is used for heating or cooling. So if I push that up, for example, I am heating, and let's just observe what happens to the molecule, and in particular what happens to the pressure and to the temperature. We can see that is rising. So increasing the temperature causes the volume also to increase and causes the pressure to rise. I can reduce I can reduce the volume by pushing here, and if I do that, accordingly, it affects the temperature and it affects the pressure of the gas. If I reduce the volume, or I increase the volume, the pressure decreases and the temperature also decreases. So if changing any of these three causes the other two also to change, so that this ratio is always constant. And this is the equation for the state of an ideal gas. So this particular relationship, which is what we would refer to as gas laws, okay, which is what gas laws are, kind of reminds me about, relates for me with the triangle laws, okay? So if you can understand what's happening here, then it kind of also helps you see how triangle laws work, because in triangle laws, the side, the area, and the angles of the triangle, if you change any one of them, then the other factors will also change accordingly, so that certain things remain fixed. All right. So gas laws kind of should remind you of how the triangles laws also work. All right. So we'll move on to the next. And so here is a standard triangle. This triangle is such that it has the vertices A, B, and C, and you will notice that the side that is opposite the vertex A is the length of that is small letter a. Similarly, the length of the side that is opposite to the angle B is small letter b. The side that is opposite to the angle C is small letter c. Okay? The area of this triangle as it is right now, so we could think of this triangle as being in this particular state, right? Now, if I try to change the length of one side, the other properties will change accordingly. So for example, if I try to change, I'm going to try and change the length of side B by just moving side edge C closer, the angle C closer to angle A. So by doing this, I'm changing the length of side B, and accordingly you can see the area is also changing, but so are the angles. So if I try to change any of this, if I move point C, you can see that the angle, the area is changing, some angles there are also changing. So by trying to change any one of these, trying to change an area causes one or more of the other aspects of the triangle also to change, okay? So this, we're going to see how the different sides of the triangle relate to the angle and to the area of the triangle, all right? So when we discuss the triangle rules, we will be looking at relationship or formulas that relate the angle to the sides and to the area of the triangle. Okay, so let's go to the let's go and start with the area of triangle rule. Okay, yep. So here is an opening problem. This is a real past paper exam question. So at the end of this video, you should be able to find the area of a triangle given the length of two sides and what we refer to as an included angle, right? But we'll look at other examples as well. So we are starting with the area of triangle rule. So there is a rule that relates the area of a triangle and the sides of that triangle, and this is different from the basic formula for the area of a triangle, which is a half base times height, especially when we do not know the height of the triangle. Okay, so if we know the height and the base of the triangle, then it is possible to find the area of that triangle. But if we don't have that, we have two sides of the triangle, for example, and maybe an angle, we can still find the area of the triangle, okay? And this is where this is headed. So here is an example of such a question. We will answer it after we have gone through the discussion, all right? So a triangle ABC has the sides BC as 7 centimeters, AC is 5 centimeters, and the angle ACB being 30 degrees. Find the length of the side AB. So here is our triangle. So let's consider this triangle ABC. So we have side A, side B, and side C, And again, remember the side that is opposite to angle A, this is side A. Okay. All right, so that's side A. The side which is opposite to B would be lowercase b, and the side that is opposite to angle C is lowercase c. All right, so those 3 points there. Right, we draw a perpendicular to join the bottom side AC. So there is a perpendicular joining side AC at the point D. We will also give that perpendicular height there a name H. All right. So when we look at this, we can use our basic trigonometric rules. We know basic trigonometric ratios. If we consider the triangle ABD, then we can say that sine of A is H over C, the sine of an angle being opposite over hypotenuse. So from the basic trigonometric ratios, sine A is H over C, and therefore we can find H in terms of sine A and C. Okay, that gives us H is C sine of A. I think we can put that aside. Okay, let's put that up there. All right. Of course, we could also have reasoned that sine of C is also H over A. But right now, let's work with this. Eventually, that leads us to the same thing. Okay, so since we know H is now C sine A, we can use the basic trig rule. So the area of triangle we know is given by a half base times height. Some people like to write base times height, everything divided by 2. Doesn't matter, same thing. So if we substitute in for H, remember H is C sine A, we can then write that the area of the triangle is a half B times C sine of A. So which is to say that I don't really need to know the value of H. I can find the area of this triangle if I know the length of that side, and I know the length of that side, and I know the angle that they form. The angle that they form is called the included angle. We'll talk about that briefly. And so this is a formula straight away that we can use to find the area of a triangle when we do not know the height of that triangle. So if we know the length of two sides, which are called the forming sides, and we know the included angle, then we can find the area of the triangle. Okay? Of course, we can reason that sine C, now that was working with sine A, we can also reason that sine C is opposite over hypotenuse, which is H over A, and therefore the same H can be described using angle C as opposed to angle A there. All right, so if we do that, put that aside, and we can conclude immediately. So in place of H, instead of putting C sine A, we put A sine C, and we get the area of the triangle as being a half AB sine of C. All right, we could have drawn a perpendicular instead of this H here. We could have drawn a perpendicular from A to join BC, and then talked about angle B there, and we would still come up with a formula that is similar to this. We would come up with a formula that the area of the triangle is AC sine of B. So if we know, in short, so if we know side A, B, and the angle that they form, then we can use the same rule, half AB sine C, or half AC sine of B, because A and C form angle B. C and B form angle A, so we could find the area by saying half BC sine of A, like that. So these three formulas can be used to find the area of this triangle. That's really it. And this is the area of triangle rule. Okay? Let's see. All right, so the vocabulary here, that the things that you want to remember is what we mean by the included angle. So when we want to find the area of a triangle, we need to know two forming sides. So if we use this formula here, then B and C are referred to as the forming sides, and angle A is referred to as the included angle. So the included angle is the angle made by the two forming sides. So C, forming side C and A here, will give us the included angle be, and so on. Okay, so that vocabulary, included angle and forming sides, is important. Okay, now let's see if we can solve that the opening problem. A triangle ABC has the side BC as 7, AC as 5, and angle ACB as 30 degrees. Remember that curve there means that we are talking angle C, really. Okay, find the area of the triangle ABC. So here we go. Here's triangle ABC, side A, side B, and side C. And side BC is 7 centimeters. Side AC, that's this one here, is 5 centimeters. And angle ACB would mean angle C there. So the cup is on C there in the middle. So that's 30 degrees there given to us. Okay, we want to find the area of the triangle. So we know the two forming sides and the included angle. Okay, so if we know the forming side and the included angle, we don't need to see letters. All right, so otherwise that would be side B and this would be side A. So the area of our triangle would have to be a half A times B sine of C, okay? But we don't need to see those letters. We just need to see the length of the sides given and the angle that they are forming there is also given. That's enough to help us find the area of this triangle. So what's the area of the triangle? Okay, so as you see, we need two sides and the forming angle, or the included angle, which is 30 degrees. So by the area of triangle rule, the area is a half AB sine C, which we have everything that we need. And so substituting a half is 0.5 times A, which is 7, times B, which is 5, sine of 30. The sine of 30 degrees, if you check your calculator, that should be a half. So if we multiply that out using a calculator, we end up with an area of 8.75 centimeters squared. So that's the area of that triangle. Really, really easy to do these questions. Let's see if there's another one. Example 2. Find the area of the triangle below. Okay, distances are given in centimeters. All right, so we have two sides and the included angle as we require, and therefore using the same idea, by the area of triangle rule, area is a half AB sine C, so this would be like our A and B. You don't need to see letters, okay, so that you know which angles to use. So we just need to say a half times 3 times 3 root 2 times sine of 135. Sine of 135 is the same as sine 45, which is the same as root 2 over 2, or 1 over root 2, or 0.7071. So if we do that calculation either way, we end up with 4.5 centimeters squared. So the area of this triangle is 4.5 centimeters squared. Okay, right. Here is a turn for you. Please find the area of the triangle that is given below. Try it out and see what you get. You will need your calculator. All right. Here is another one. Question number 2 is also for you to try out. Okay. All right. So if you see in this particular question 2, we are now given the area and we are given one side, we are given the angle, but we don't know the length of that side. So in this question, we are looking for the length of the side X instead of the area. We should still be able to do it easily, okay? Here's another one, question number 3. Again, you're given the area, you're given the sides, but now we don't know the angle. So in this case, you are looking for the angle. I want you to try that out. The formula remains the same. It's a question of substitution, okay? All right. Sometimes it is the angle that we are looking for, such as this case. Please try out this question. And sometimes we can also relate trigonometry with other areas of the course, as you can see. All right. in this particular case, you will notice that this is going to drive you into quadratic equation. All right, so you're going to be solving a quadratic equation eventually. Please try it out. I shouldn't have given that hint, but there it is. You will find the value of x, all right, and then we will discuss your solutions after that, all right. That brings us to the end of this session on determining the area of a triangle when two sides are given together with an included angle. All right, see you in the next part, which is going to be the sine rule.